All right, in homework 10.3, you are doing some matrix operations. The first matrix operation that we learned about was adding and subtracting matrices, and in order to add and subtract them, the dimensions need to be the same. I'll help you out with number 4, which I think will probably be the trickiest one for you guys. Number 4, the first thing to start with is, since we're adding, we need to check and see if the dimensions are the same. There's one row, 4 columns. This is a 1 by 4 matrix. One row, 4 columns. This is a 1 by 4 matrix. And since they have the same dimensions, you can add them. And the way you add them is you just add each of the entries together. So you add the first row, first column, plus the first row, first column. The reason I'm going to help you guys on this is I suspect some of you might have some middle school troubles that you need some help with. So 2/3 plus 4/3. I'll do it off to the side here. So our answer matrix is going to be a 1 by 4 matrix also. And when we add the entries, they just go in the same spot as they were in the matrix. So we've got 2/3 plus 4. Man, I wrote that really ugly. I don't know why I did that. 2/3 plus 4/3. When we add two fractions, they need to have the same denominator, and these do. And if they have the same denominator, you just add the numerators. So this is 6/3. And we can simplify 6/3. 6/3 is 2. So 2/3 plus 4/3 is 2. Next, we need to add 5/6 plus negative 7/2. So 5/6 plus negative 7/2. These two fractions do not have the same denominator. And so in order to be able to add them together, we need to make the denominators the same. And we do that by multiplying by 1 in a special way. 3 divided by 3 is 1, so multiplying by 1 doesn't actually change anything. We can multiply by 1 in the fraction. We'll still have the same value. This is 5/6. Adding a negative is the same as subtracting, minus 21/6. Once they have the same denominator, you can just subtract or add the numerators. 5/6 minus 21/6 is negative 16/6. And this, of course, can be simplified by dividing by 2 in both the numerator and the denominator. This is actually dividing by 1, just done in a funny way. So it's negative 8/3. That's our second entry. Our third entry is 2 plus 1/8. 2 plus 1/8. Here we've got a whole number plus a fraction, and you can't add unless you have two fractions with the same denominator. So 2 plus 1/8. We need to have eighths. 2 is 2 over 1. And then, similar to before, we can multiply by 8 over 8, and that's 16/8 plus 1/8. Sometimes people will just skip straight from here to here. They say, you know what, I know I need to have eighths. So they'll say, hey, it's got to be eighths. 16 divided by 8 is 2, so 16/8 plus 1/8 is what we're doing here, and that is 17/8. So 17/8. The last thing is, oops, sorry about that. The last thing is we've got negative 1/2 plus 6/5. So I'll do that right here. Negative 1/2 plus 6/5. These don't have a common denominator, nor can we just multiply 2 to get to 5 very easily. The way we do this is we multiply both of them by each other. So we multiply by 2 over 2 here. We multiply by 5 over 5 here. And so we get negative 5/10 plus 12/10. And now we both have tenths, and so we can add them together. Negative 5 plus 12 is 7/10. So 7/10. That's my matrix in the end. This is my final matrix. Okay, let's see, next thing. Multiplying a constant, we're multiplying a scalar by a matrix. And when we multiply a scalar by a matrix, it just multiplies times each one of these. You can think of it like distributing. So first, we're going to have negative 5x to the 6th times 2/5. And recall from Algebra 1 that when you multiply, you just multiply the coefficients. When you have a constant times a constant with a variable, we can just multiply negative 5 times 2/5. And there's two ways to do this. One, you could change negative 5 to a fraction. Negative 5 over 1 times 2/5. That's negative 10/5. And then we can simplify that. Negative 10 divided by 5 is negative 2. So our answer is going to be, the matrix is still going to have the same dimensions. We're going to have negative 2 x to the 6th we multiplied the constants together, and we kept the x to the 6th there. There's a shortcut way to do it here, which is that if you see that you're dividing by 5 and multiplying by 5, you can cancel that out. Dividing and multiplying are inverses, so you just get -2. So that's kind of how I would have done it from the very beginning. All right, next, -5/6 times 2x, -5x to the 6th times 2x, multiply the coefficients, so we're going to get -10. X to the 6th times x, you've got 6x's multiplying times another x, that is x to the 7th. Okay. Next, we're going to do -5/6 times -3x to the 5th, so -5x to the 6th times -3x to the 5th. That is, we're going to multiply the coefficients, 15, and when you multiply, you add the exponents, so it's x to the 11th. Our last one, we've got -5x to the 6th times -4 over x squared. Here we've got a whole number times a fraction. Just put the whole number over 1 and multiply straight across. This is +20 x to the 6th divided by x squared. And recall from Algebra 1 that if you divide, you can subtract the exponents, and so this is going to be 20x to the 4th. All right, so next we've got multiplying, and this is actually the tricky part of matrices. I think. When you're multiplying, the first thing to do is to write the dimensions of the matrix. So I'm going to do number 10 here, and in number 10 we have a 2 by 2 matrix, 2 rows, 2 columns, 2 rows, 3 columns, so 2 by 3 matrix. To be able to multiply them together, the two middle dimensions need to be the same as each other. These are equal, which is good. And the result matrix will be whatever's left over, so a 2 by 3 matrix. So here's our 2 by 3 matrix. And the way we multiply is we multiply each row by a column. So first row, first column, you multiply the first entry times the first entry. So -5 times -x is 5x. -6 times y is -6y, and we add them together. So 5x minus 6y, that's all one entry. Next we multiply first row times second column. -5 times 1 is -5. -6 times 5 is -30, so it's -5 minus 30, and we will combine these in a second because we can. And our last thing is -5, -6 times -2, -3. -5 times -2 is 10. -6 times -3 is plus 18. We'll combine those in a second also. This is all one entry. After we've done the first row times each of the columns, we do the second row. And this will go in the second row of our result matrix. So second row times first column, -2 times -x is 2x. -5 times y is minus 5y. That's all one entry. We can't simplify it. Then we do -2 times 1, -5 times 5. So it's -2 minus 25. And finally, -2 times -2 is 4. -5 times -3 is 15. This is our result matrix. We can simplify some of the entries, so we will. This is minus 35, -5 minus 30, 28, 2x minus 5y. This is -27, and this is 19. So that is our multiplication of matrices. One thing to be careful of is they do have to have the correct dimensions to be able to multiply them. On number 12, this is a 1 by 4 matrix. 1 row, 4 columns. This is a 1 by 2 matrix, and because the two middle entries are not the same, this matrix cannot be multiplied, and the answer is undefined. The reason it's undefined is you're supposed to multiply each row times each column. Well, okay, so 0 multiplies by 5, but then these other ones don't have anything to multiply by. So you would need to have the correct number of entries there for it to line up, and they don't. Hopefully that helps in your homework and the rest of it goes well.